Hello, hello everyone. Today we're going to do maths. So this is quadratics, and I've prepared some problems for you today. We'll be starting in a minute. If you can, in the chat, can you tell me how many problems have you managed to do in the maths? So there are somewhat 18 problems there. Okay, so 5, everything. Oh, brilliant. 11, 6, 16, 13, 18, brilliant. 18. Okay. Right. So I'm going to go through some standard questions, some less standard questions. So yes, and hopefully it'll be useful for you. Okay. So let's start. Okay, you should be seeing my screen now. If you don't see my screen, let me know. And if you also let me know if you can't hear me. Okay, so quadratics part 2, let's go. Problem 1. Without solving the quadratic equation, find the roots. We have done the first part last week, 2 weeks ago, sorry. So let's just do a quick recap of what we did. So we used the Vieta's formulae. And we recognize that x1, x2, the product of the roots is 2/3, and x1 plus x2 is minus b over a, so it's 8/3. And then what we need to do is find x1 squared plus x2 squared. Well, x1 squared plus x2 squared. What is that? Well, we remember that x1 plus x2 squared, if we do this, it sort of looks like this. It's x1 squared plus 2x1 x2 plus x2 squared. So from here, we can write down x squared plus x2 squared is equal to x1 plus x2 squared minus 2x1 x2. Okay, I so hope that makes sense. And because we have these values, so x1 squared plus x2 squared is, we got this by rearranging this expression, and this expression is just a square of a sum. So I hope you understand what's happening here. Now we do x1 squared plus x2 squared is this. Therefore, x1 plus x2, that's 8/3 squared minus double 2 times 2/3. By the way, this is a reason why in maths we don't use mixed numbers. If you write 2/3, it normally means multiplication, right? Okay, to be clear, you do put multiplication here, but yeah, we teach you mixed numbers. Well, this in school they teach you mixed numbers, and then you never use them. The only place you actually use them is I don't know, cooking. Take 2.5 cups of butter or whatever you put when you're cooking. But then you never use mixed numbers. We always use top-heavy fractions or improper fractions. Okay, 8 squared, so 64 ninths, and this is 4/3 minus 4/3. Let's multiply it by 3, so it's minus 12 ninths, which gives us 52 ninths. I wonder if I got the same answer 2 weeks ago. Let's have a look. Where is it? Yeah, 52 ninths. Okay. Now let's do the second one. And so this is A. I had a question regarding this section. In this section criteria, just the scores of the 2 assignments, or just depends on something like presentation or work participation. Okay, just the scores, but you can't do like I don't know, 10% physics and 100% maths. Okay, it doesn't work. You'll need to do decently on both. But by decently, in the last 2 years, decently meant more than 40% for each maths and physics, and more than 50% average. I don't know this year, but it shouldn't be too different from that. Okay, B, we have 1 over x1 squared plus 1 over x2 squared. So what do we do here? Well, we find the common denominator, of course. So we multiply this by x2 squared and this by x1 squared. So x2 squared plus x1 squared divided by x1 squared x2 squared. Oh, what an interesting coincidence. We already have the top part. The top part is 52 over 9. And the bottom part is just x1, x2 squared. And this one is x1 squared plus x2 squared. So all we need to do is 52 over 9 over x1, x2, so that's 2/3 squared, that's 4 ninths. So that's 52 fourths, which is 13. Oh, that's nice. Would you still get marks in physics for the right method, even if you don't get the right answer? Yes, of course. You get method marks. All right. I like to say them progress marks. How much progress have you made towards the final answer? Yeah, so for example, if you have a physics problem, I don't know, something rolling down a hill, you have you need to use conservation of energy, then you need to use the equations, you need to use Newton's second law. So depending, and then you need to write down equations, and then you need to get the answer. So this is a huge stage. You use conservation of energy. Okay, you get a mark for that. You use Newton's second law. You realize that you need to use Newton's second law. You get a mark for that. So it's just like, how far have you moved towards? How far have you progressed towards the answer? What are Vieta's formula? I missed last session. Could you just write them out? Well, they are in the assignment, like literally in the, that's one of the first things. The Vieta's formula is that x1, x2 is equal to C over A, and x1 plus x2 are equal minus B over A. So these are the Vieta's formulae, but you need to refer to the assignment, please. Yes, thank you. Yes, thank you those who are answering this in detail. That I'm very grateful for that. So do proof questions require written proof, or can we just proof proof square? Proof square. What do you mean by proof square? Actually, I don't think we have any proof questions. We shouldn't have any proof questions. We have show that questions. A proof square. Yeah, QED is fine. I mean, show that questions. Yes, QED is fine. You don't. Oh, you didn't. I'm not 100% sure what you're asking, but if you need to show that something, yes, you show that, and then at the end you say, "Ta-da, QED." Problem 2. Find the value of k such that the product of the roots of the equation is equal to 0. Now, this sounds more complicated than it is. It's actually very simple. What are the values of k such that the product of roots of the equation is 0? Okay. Well, we need to work out what we're dealing with. It looks like we're dealing with a quadratic equation. But instead of c, we have this expression here. We have an expression in terms of k. This is known as an equation with a parameter. Equation with a parameter. So a parameter is a constant. So k is the parameter in this case. A parameter is a constant that affects the equation. So let's have a look. So let's go to Desmos. Let's have y equals x squared minus 4k minus 1 x plus I don't know, something like k over 9 equals 0. Oh, k over 9. Add slider k. So k is the parameter. And you can see that this is a parabola. And k does something. So let's see what happens if k changes. So k affects this function, right? So this is a function, but it not only contains x, it also contains k. K is treated as a constant. It's not a variable. It is a constant, but it can take different values. It's a constant. It's not a variable, but it can vary. That sounds ridiculous, but so see what happens when I change k. Right? I don't want it k over. Let's make it less obvious. So you can see that when I change k, the parabola changes. Something happens to it. You can have more than one parameter. You can have another parameter, a, for example. And now you have two parameters, k, that changes the vertex. And you have an a, which changes the appearance of the parabola. So yeah, so we have two parameters. Okay. So this is the idea of a parameter. Now this equation contains a parameter, and depending on the parameter, the equation behaves differently. So it is equal to 0. So, okay, what do we need? Well, we recognize this is a quadratic equation. So a equals 1, b equals 3, and c equals k squared minus 7k plus 12. We know from Vieta's formula, is that the product of roots, x1, x2, is equal to c divided by a, which is k squared minus 7k plus 12, divided by a, which is 1, Well, so this is x squared minus 7k plus 12. And we know that's equal to 0. Oh, that's equal to 0. And this we can solve using Vietas again. Yeah, the power of Vietas. We can also, of course, you can factorize it, but I think Vietas is even faster than factorizing. K1, K2 is C over A, which is 12, and K1 plus K2 is 7. Well, K1 is 3, K2 is 4. Ta-da, that's the answer. That's it. You don't have to write a QD in the end, by all means, write it down. You still get marks if you don't write it. It's not a big deal. It's a nice thing to have. In the equation, this is okay. How well do you understand problem 2 on a scale of 0 to 10, please? I'm particularly interested in those who are not 10s. So please let me know. Okay. Okay. So Imeth, anything in particular, and Ananya, anything in particular you're confused with? How can I help your understanding? Oh, perhaps my use of Vietas might have been confusing. Are you confused how I solved it, or are you confused about the idea of a parameter? Please let me know. How you solved this one, this bit? Well, I used the Vietas formulae. The Vietas, if you're not familiar with the Vietas formulae, please watch the webinar from 2 weeks ago. Also, I have more recordings of Vieta's formula. Basically, I find two numbers which multiply. Why don't we also use x as a b coefficient values? Well, x is a variable, is a v variable, and a, b, and c are constants, coefficients. So the quadratic equation is ax squared plus bx plus c. That's a quadratic equation where a, b, and c are coefficients. You could also call them parameters. No, actually, calling them parameters doesn't make any sense because they can't change. So ax squared plus bx plus c. Then we have the Vieta's formulae say that if x1 and x2 are roots, then x1 multiplied by x2 is c over a, and x1 plus x2 is minus b over a. So that's what I did here. K1 times K2 is 12, and K1 plus K2 is 7. So what could K1 and K2 be? Well, the only option is 3 and 4. And that's it, 3 and 4, because 3 times 4 is 12, 3 plus 4 is 7. That's how I found them. That's how I did it. So if you're confused with the Vieta, please watch the previous webinar. Here we have another quadratic equation. Now, it's going to be a bit confusing because a equals 1, b equals minus 4, and c equals a, because we've used a as the parameter. Okay. In the equation, the sum of squares of the roots is 16. Find a. Okay, so let's use Vietas here. Vietas. Again, we have x1, x2. X1, x2 is equal to C over A, which is A over 1, so A. Then we have x1 plus x2, and that's going to be minus B over A, which is 4 over 1, which is 4. Okay. And they tell us that the sum of squares, so x1 squared plus x2 squared, is 16. So how do we make any sense of this? Well, it's very similar to what we did before. So from here, we can say, okay, well, if x1 plus x2 is 4, we can square it. x1 plus x2 squared is going to be 16. Open the brackets, is going to get x1 squared plus 2x1 x2 plus x2 squared is 16. But they have told us that x1 squared plus x2 squared is 16. So this thing is 16 as well. 16. Therefore, 16 plus 2x1 x2 is 16. In other words, 16 cancels. We have 2x1 x2 is equal to 0. x1 x2 is equal to 0. But x1 x2 is A. Remember, this is A. Therefore, A equals 0. Simple. Simple and straightforward. Okay. So that's how we do question 3. The sum of the square of the roots. So you write down Vietas and then you work out. So this is very similar to what we did before. So this is similar to what we did here. Next question, problem 4. Solve the equation. Now, I don't know if you did functions. You should have done functions in GCSE. But if you're slightly confused what a function is a rule the function is a rule of how to transform numbers. Okay. Right. So we have an equation. This is an equation because it contains the equal sign. On a scale of 0 to 10, do you think, okay, do you understand what f of 1 over x means? Do you understand what this means? On a scale of 0 to 10, please. Okay. Okay. So I will go through this. It is a function. So I've seen a few people are don't fully understand. So that's absolutely fine. A function. A function is a magic box. F of x. You put something in, so you put in x, you get f of x. If you put something else, I don't know, a, you get f of a. If you put a zebra in, you get f of zebra. Well, as long as you're allowed to put zebras into the box. Because we have something called the domain, which tells you what you can and what you cannot put into the function. So a function is a rule, is the stuff that you do to x to get f of x. So in this case, the stuff that you do, you add 1, then you divide by the initial number squared. So if f of x, so f of x is equal to x plus 1 over x squared, then f of a would be a plus 1 over a squared. F of zebra is going to be zebra plus 1 over zebra squared. So it doesn't work. So it works. So that's what functions do. Therefore, if you have f of x, well, f of x is given to us. So f of x is equal to f of 1 over x. We need to work out what f1 over x is. So we know how this works. So f of 1 over x must equal to 1 over x plus 1. We're just using the same thing over 1 over x squared. And that's what we plug in here. So this is x plus 1 over x squared is equal to 1 over x plus 1 over 1 over x squared. So what I did is I replaced x with 1 over x. That's how functions work. Okay, so here I have x. Here I replaced x with a. Here I replaced x with zebra. So here I replaced x with 1 over x. I hope that makes sense. And then you do something, do stuff to it, basically. Okay, so you find the common denominator here. Okay, so that makes it 1 over x plus 1. So it's going to be, you multiply this by x, so it's going to be 1 plus x over x divided by 1 over x squared. The easiest way to do is write it like this: 1 plus x over x divided by 1 over x squared, which makes 1 plus x over x multiplied by x squared over 1. X squared cancels, and we're left with x multiplied by x plus 1. So overall, we have x plus 1 over x squared equals x multiplied by x plus 1. This is our equation. And now x plus 1 over x squared. So you multiply both sides by x squared. So it's going to be x plus 1 equals x cubed, x plus 1. I multiplied both sides by x squared. Should I expand the brackets? Can somebody help me? Should I expand? Ooh, interesting. Ooh, very good. Cancel the x plus 1. Good one. There's a rule. There's a rule in maths. You cannot cancel something if that something could be 0. Okay, I will demonstrate. So, let's say, so paradox. Well, it's not a paradox, it's a paradox. Paradox. Let's say A equals B. Multiply both sides by A. We get A squared equals AB. Subtract B squared from both sides. We get A squared minus B squared equals AB minus B squared. Factorize. We factorize this. This is A minus B, A plus B. And this is B, open bracket, A minus B. A minus B cancels. We're left with A plus B equals B. But remember, but B equals A from the start. A equals B. Therefore, B plus B equals B. 2B equals B. In other words, 2 equals 1. Yes, it is a proof that 2 equals 1. It's not proof, it's proof. It's rubbish. So what did I do wrong here? What? Yes, A minus B is 0, and I am not allowed to divide by 0. I'm not allowed to cancel because A minus B is 0, where I'm dividing by 0, and that's why my answer is nonsense. If you divide by 0, you can get all sorts of nonsense. Therefore, this paradox, and the same goes here. Before you divide, if you want to cancel the x plus 1, you have to make sure that x plus 1 is not 0. There are two ways you could do this. You could say, okay, what if, you ask yourself, what if x plus 1 is 0? Well, that means the 0 equals 0. We have 0 equals 0. So we have true. So x equals minus 1 is a solution. And then we say, suppose x plus 1 is not equal to 0. So we've looked at it separately. And now we do x plus 1 is not 0. And now we divide. We divide by x plus 1. We're allowed to do that. So it's going to be x plus 1 equals x cubed x plus 1. We divide, we're left with 1. We have 1 equals x cubed. X is equal to 1. So there are two solutions, x equals minus 1 and x equals 1. Now, if we just did this, we would have lost the x equals minus 1 solution. This is option 1. Let's call it option 1. Option 1. Option 2. Karim, sometimes quadratics have 4 solutions. Quadratics can have up to 4 solutions. Let's put it this way. Okay, they can have up to 4 real solutions. If you're talking about complex solutions, then yes, they have 4 complex solutions always. Just, yeah. If you're talking about real solutions, then it's 0, 1, 2, 3, 4. Anywhere between 0 and 4. Option 2 is we don't divide by anything. We subtract x plus 1 from both sides. So we do x cubed, x plus 1, minus x plus 1. I've put them in parentheses, and that should give you a hint. And now you can see that x minus x plus 1 is a common factor. So we take x plus 1 out of the bracket, and we are left with x cubed minus 1 equals 0. So we have x plus 1 equals 0, or x cubed minus 1 equals 0. So here x is equal to minus 1, or x cubed equals 1, x equals 1. Still the same solution, the same answer. Could you go back? So if you want to have a look at my working, just here's my here's the link you can use. Here's the link you can use to view the board in your own time. Okay, so you don't have to follow me. Those of you who have for whom this is easy, you can move on to the next problems. So the next problems are, oh, that's an interesting one. I mean, it's a bit skipping ahead. We're going to do this later on in our course. We're going to do equations with square roots. However, I did want to do this one because it is sort of a quadratic equation. There are two ways you can approach this. So method one, and this is a substitution. Let's say, u is equal to square root of 2x minus 1. Okay, so then u squared is equal to 2x minus 1. So the equation becomes u squared equals 3u. And I'm sure you can, okay, let's do u squared minus 3u equals 0. u minus 3 equals 0. u1 equals 0. u2 equals 3. The two solutions. Now, if u1 equals 0, that means square root of 2x plus 2x minus 1 is equal to 0. And or square root of a number is 0, that means that the number is 0. 2x minus 1 must equal to 0. So 2x equals 1, x equals 1/2. So x1 is 1/2. The second option is that square root of 2x minus 1 is 3. Well, which number, square root of which number is 3? The number is 9. So 2x minus 1 is 9. So 2x equals 10, x2 equals 5. The second solution is 5. That's the first option. That's how you can, that's the first way of doing it. Method 2 is a bit more blunt. Method 2. Square both sides. Raghav, no, because you cannot have 2x minus 1 is 9, because square root of 9 is 3. Square root of minus 9 is not 3. Square root of minus 9 is not 3. How do you get 3u? Well, I said u is square root of 2x minus 1. U is this. And this is 3 times that, so 3u. And then 2x minus 1 is u squared, because that's how square roots work. Yeah, that's fine. Don't apologize, Raghov. I mean, it's perfect. That's perfectly okay. You have u is that, so u squared is 2x minus 1, so it's here, 2x minus 1. So that's u squared, and this is 3u. That's what we got. Does that make sense, Amy? Okay. The second method is a bit, as I said, it's a bit more straightforward. It's a bit more blunt. Square both sides. Sides. Why are we allowed to do this? Well, if a equals b, then a squared equals b squared. It doesn't work the other way around, though. Yeah, if this is true, it doesn't mean that this is true. I hope you understand that. It doesn't work backwards. If a squared equals b squared, then not necessarily a equals b. So that's these are important things when you're talking about like proofs and stuff. Just to be aware of. If a equals b, then a squared equals b squared. So you have 2x minus 1. So you have 2x minus 1 is equal to 3 square root 2x minus 1. So you square this. So 2x minus 1 squared is equal to 3 square root of 2x minus 1 squared. So square both sides. So 4x squared plus minus 4x plus 1. So open this. That equals 9, open bracket 2x minus 1. 4x squared minus 4x plus 1 equals 18x minus 9. And this goes 18, so 4x squared minus 22x plus 10 equals 0. Simplify by 2. So that's going to be 2x squared minus 11x plus 5 equals 0. And I'm going to be clever here. I'm going to use Vietas today. I'm going to say, okay, x1, x2, the product is 5 over 2. And x1 plus x2 is 11 over 2. Okay, so we're adding two numbers and it makes 5 over 2. So we're multiplying two numbers and it's 5 over 2. We're adding two numbers and it's 11 over 2. So how about 5 and 1/2? Does that work? Well, 5 times 1/2 is 5 over 2. 5 plus 1/2 is 11 over 2, 5.5. So yes, it works. 11 over 2. It works. So works. That means x1 is equal to 5. x2 equals 1/2. Is that what I got? Yeah, that's what I got. Okay, the same two answers. Why is this the case? Or TJ, can you clarify? What do you mean? What is the case? If a squared, are you asking if a squared is equal to b squared, why is it not true that a equals b? Well, let's say we have, well, if a equals b, then it is not true that square root of a equals square root of b. That it doesn't work like that. That doesn't necessarily work. But the other way works. If square root of a equals square root of b, then a equals b. That is true. But the other way, it doesn't work because, well, if -3 is equal to -3, it does not mean that square root of -3 is equal to square root of -3, because square root of 3 does not exist. So it does not follow. Then you have a squared. So -3 squared is equal to 3 squared. This is a true statement because -3 squared is 9 and 3 squared is also 9. But it does not mean that -3 is equal to 3. So that's why it doesn't work the other way. The other way it works, if 3 equals 3, then 3 squared is equal to 3 squared. But the other way, yeah. Well, this statement will obviously work the other way. So, okay. Sorry, quick question. In physics, if you draw an accurate vector diagram on a hard question, you still get a mark. Yes, if you get it's not about accuracy. Well, it's about the accuracy of physics, not about the accuracy of your lines. Yeah, so it has to be make sense from the point of view of physics. Okay. So problem 6 and problem 7. Oh, I love problem 7. Problem 6. I really hope that I haven't accidentally given you the same problem for. I was about to do the question from the assignment. Okay, I won't do that. Let me see if I have a different one. You're so lucky that I spotted that I accidentally almost did this. Okay, so x plus x minus 1, 4 minus x squared plus 2x minus 73. Are all these problems from past assignments? No, these problems are from different books. And some of them are from my head. Some of them are, yeah, from different places. Like, you'll be embarrassed to know which book this question is from. And this question is from Algebra Year 8. It's just in some countries, maths is harder. So, yeah, this is Algebra Year 8. Book. Okay, so have I done it? Have I messed it up? I have messed it up. It's not 78. It's 73. 73. Okay, so it looks like it looks like a quadratic equation. Now, I wouldn't give you a quadratic equation because quadratic equations are hard. They are they're too complicated. So perhaps this is not a question about long division, but there. Yes, Isa, thank you. You can complete the square. Look what happens if you complete the square to the power 4 minus x squared minus 2x plus, well, you don't even need to do 73. Forget about the 73. So minus 73 equals 0. You can complete this square. Look, x minus 1 to the power 4 minus x squared minus 2x plus 1 minus 1, close bracket, minus 73 equals 0. And you do x minus 1 to the power 4 minus, this is going to be x minus 1 squared minus 1 minus 73 equals 0. X minus 1 to the power 4 minus x minus 1 squared plus 1 minus 73. So minus 72 equals 0. And this is familiar to us. This is substitution. This is let u equals x minus 1 squared. Then u squared is x minus 1 to the power 4. And this is u squared minus u minus 72 equals 0. I'm going to use the Vietas here again. Well, because I want to complete the square. So I have x squared minus 2x. What am I missing? Like x squared, so the question is, why did I do plus 1 minus 1? So I did plus 1 minus 1 because I need this. X squared minus 2x. What am I missing here for it to be a complete square? To make a complete square, I need 1. But I've just changed it. I just added 1. So what I do minus 1 to compensate. Then I put this into brackets, and this is x minus 1 squared minus 1. And if you expand this, if you were to expand this, this is going to be x squared minus 2x plus 1 minus 1, which makes it x squared minus 2x. Ta-da. Yeah, but 73 doesn't make a complete square. You need 1. Well, not only that, you need a very particular square number. You need 1. There's no other number would fit because it's x squared minus 2x plus something. Well, it could only be x minus 1 squared, which is x squared minus 2x plus 1. So this is a complete square, so it has to be 1. If it was like 3, this wouldn't be 1. This would be 9 over 4. It is half the coefficient of x. Yes, it's half the coefficient of x squared. So the formula for completing the square, it's in the assignment, is x squared plus bx plus c is x plus b over 2 squared minus b over 2 squared plus c. This is the formula for completing the square. Like, so that's what I did here. So I did x squared minus 2x minus 2x is x minus 1 squared minus 1 squared plus 0, which is x minus 1 squared minus 1. That's what I did. It depends. I use the formula with where a equals 1. If a is not 1, then you use a different formula, b over 2a. This is a more complicated formula, and I mean, I wouldn't use it. Like, look, if I had 3x squared plus 6x plus 7, what I would do, I would take 3 out. 3 open bracket x squared plus 2x plus 7 over 3. And then I say, okay, 3. I forget about the 3 for now, and there's going to be x plus 1 squared minus 1 plus 7 over 3. So it's plus 4 over 3. And then I get 3 x plus 1 squared plus 4. So I get rid of the 3 and then I take it back. That's what I do with a. I don't. There is a formula where you have a, but it's just I find it too complicated. It's not. I don't like it, but you can use it by all means. This is an example. Where a is not equal to 1. Thank you. So let's go back to this question. We have u squared minus u equal minus 72. I'm going to use Vietas again. Vietas. So u1, u2 is negative 72, and u1 plus u2 is minus 1, plus 1. Sorry. So which numbers, which when multiplied make 72, and when added is 1? Well, obviously it is 9 and minus 8. u1 is 9, u2 is minus 8. And then we have, that means x minus 1 squared equals 9, and x minus 1 squared equals minus 8. This is not possible. X belongs to an empty set. Not possible. No solutions. Because a square cannot be negative. X minus 1 squared equals minus 8. And here we have x minus 1 is equal to plus or minus 3. So x is equal to 1 plus or minus 3. X, I see a lot of messages. I don't see the messages, but I see messages coming in, and I'm always thinking, oh, I must have made a mistake, and you're correcting me. I'll check in a second. So 1 plus 3 is 4, and x2 is 1 minus 3. That's minus 2. Okay, so what have I done wrong, or not? In the assignment, there's a question where it asks to prove coordinates of the vertex, but for the y coordinate, I asked for minus b squared over. I don't know, that's a typo. No, it's not a typo. It's correct. It's just when you have a in my formula, we don't have a. The formula I've used here. But if you had a, it would be a different formula. If you had a, that would be 2. It would be a. That would be a like this. Something like that. I might have done it wrong, but just yeah, it would be a different formula. I don't believe there's a typo because we've proofread it many times over. But if you actually do find a typo, please let me know. Doesn't Doesn't matter if it's positive or negative. Doesn't matter if it's positive or negative. Oh, not sure what that means. It's the whole fraction being not b squared. It's the whole fraction being negative, not b squared being negative. Yeah, the whole fraction being negative. Minus b squared over 4. Yes, it's minus b squared. So b squared, not minus b squared, but minus b squared. There's a difference between, obviously you know that, there's a difference between minus b squared and minus b squared. So these are different, yes? So minus 3 squared is equal to minus 9, but minus 3 squared is 9. I hope everyone is clear on this. Okay, this is getting out of hand. Too much information on one sheet, so I'm just going to delete that. If it's squared, then it doesn't matter about negative, positive. Instead of the A's to delete them, could you do Control Z? I could do Control Z. Yes. Why are you asking? Is it noisy? Okay, so problem 7. Now this, we're going deeper into maths a little bit. I just want to share with you the beauty of the modulus. The beauty of the modulus. Sometimes it is. Sometimes it's more efficient. Sometimes it's not. Okay. So what is this? Like, what is this? What does this even do? There are different approaches here. Well, first approach is the clever approach. Clever approach. And the clever approach is the one that you've already used. Well, we notice that modulus x squared is the same as x squared. Does everyone understand why? On a scale of 0 to 10, please. Do you understand that modulus x squared is the same as x squared? Okay. So what does the modulus do? Well, the modulus makes the number, a negative number, positive, and a positive number positive. So let's say x is a negative number. So let's say modulus of 4 squared, or modulus of 4 is 4, so then 4 squared is 16. Modulus of minus 4 squared is, modulus of minus 4 is 4. 4 squared is 16. But so is minus 4 squared. Minus of 4 squared is also 16. So modulus of x squared, yeah, absolute value is like a magnitude. So the modulus removes the minus, but so does the square. The square removes the minus, because minus 7 squared is 49. The square removes the minus. And modulus of minus 7 is 7. It also removes the minus. And if you remove the minus and then square it, well, you get the same answer. Does that make sense? Those zeros and four, who put zeros and fours, do you understand now? Or are you still unsure? Ten now? Hossam? Saida? Okay, good. And then we can use we can use substitution. Substitution. That u is modulus x, and u squared is x squared, because modulus x squared, well, modulus x squared, which is x squared, and that makes it u squared minus 7u plus 6 equals 0. You solve it. U1. Oh, this is a special case. It's a beautiful special case because a plus b plus c is equal to 0. A plus b plus c is equal to 0. Watch the first video if you don't know what the special case is. And that means immediately that u1 is 1 and u2 is 6. That is beautiful. And we have, well, u is modulus x. So modulus x is equal to 1, or modulus x is equal to 6. How do we do this? Well, we can say, brilliant. So modulus of x is 1. So what is x? Modulus of a number is 1. So the number has to be either 1 or it has to be minus 1. The same here. If modulus of x is 6, then mod x1 is 6, or x3 is 6, or x4 is minus 6. So you got 4 solutions. The other approach is the less clever approach, but still I do want to show you too. That using definition of modulus. The modulus is defined the following way. The modulus of a number is equal to x if x is positive or 0, and it's equal to minus x if x is less than 0. This bracket in maths means or. It's either that or that. That kind of makes sense, because if x is negative, the modulus of x, so modulus of minus 7, for example, is equal to 7. So modulus of x is equal to minus modulus of x is equal to minus x, provided that x is a negative number. That's what it means. That's the definition of a modulus. So what we do is we look at two cases. Case 1. X is a positive number, is a non-negative number. Then modulus x is x. And you solve the equation is x squared minus 7x plus 6 equals 0. It has two solutions. X1 equals 1, x2 equals 6. Case 2, x is a negative number. And that means that modulus of x is equal to minus x, and the equation becomes x squared plus 7x plus 6 equals 0. And then you can solve this. This is the second special case. So x1 is minus 1, and x2 is minus 6. You have the same, so that's x3 and x4, sorry. Same answer. Which method do you like more? The first, the clever approach, or the using the definition of modulus, the second? One or two? Please vote. First. Okay, some twos. I think I've run out of questions for today. I'm happy to answer any questions if you have. Could you also solve it by getting the modulus on its own? Well, you could do it. You can use a graphical method. So 3 is a graphical method. It's not the best method in the world, but graphical method, you would say, so x squared minus 7 modulus x plus 6 equals 0. You have 7 modulus of x is equal to x squared plus 6. So what you draw two graphs. Y1 is 7 modulus of x, and y2 you draw x squared plus 6, and then you draw the graph. So 7 modulus of x, that is a graph that looks like this. And x squared plus 6, it is a graph that it looks like a parabola. So it starts here. So it's going to go like this. It's a parabola. And you can see that this graph meets the parabola 4 times. So this is x1. Well, you can see it meets, there are 4 points where it meets. This is x1. This is x2. This is x3. And this is x4. So this is -6, -1, 1, 6. This is a graphical method. I don't think there's a method where you can do just on its own. Well, you could do x modulus of x equals x squared plus 6 over 7. It's another method, but it does the same. It's the same thing. What if you don't use a plus b plus c equals 0? Well, then you don't use it. You say x1 plus x2 is equal to minus b over 2, so that's 7. x1, x2 is 6. So which two numbers give a product of 6 and add to 7? Well, it's 1 and 6. So x1 is 1, x2 is 6. So that's straight away. Okay. Of course, you can factorize it. Yes. I'm not showing you factorization because you know factorization, right? You showing you different methods. You can factorize it. You can. Okay. Well, I think we'll finish a little bit early today. Thank you for coming. Hope that was useful to you. How would you know that y equals 7, the absolute value that looks like it is? This is a transformation of the modulus of x. So modulus of x looks like this. The graph of modulus x looks like this. The graph of 7 modulus x is a stretch, is a vertical stretch, so it's going to be like this. Y equals modulus of x, and this is y equals 7 modulus of x. All right, yes, hope that was useful. See you everyone. All the lessons are available on Google Classroom. So you should have access to Google Classroom, and if you've missed any sessions, you can view the recordings. Actually, you know what? I will send you a link to the recordings right away. So if you go to YouTube and you go to YouTube. Here are the videos. Here are all the videos. All right, see you. Enjoy. You too.